if 17.2 milliliters of a 1.750 molar ammonium nitrate solution were reacted to produce dinitrogen oxide, monoxide, gas, and water, how many milliliters of N2O gas would be produced at STP? So the first thing I see in this problem is a reaction that needs to be balanced. So if I look, I have 2 nitrogens on the reactant side, and I have 2 nitrogens on the product side. So our nitrogens are okay. I have 4 hydrogens on the reactant side, but only 2 hydrogens on the product side, so I need to add a coefficient of 2 there. And now if we look, we have 3 oxygens and 1, 2, 3 oxygens on the product side, meaning that our equation is now balanced. So the next thing that I look at is I notice that I have STP. And I remember that STP stands for standard temperature and pressure, where the temperature is 273 Kelvin and the pressure is 1.000 atmospheres. These numbers are indicative of a gas law being needed, but I'll come back to that later. The other number that I noticed is my 1.750 molar ammonium nitrate. That molarity has the equation of number of moles divided by liters, and I have 2 of these 3 numbers almost ready to plug in. The 1.750 molar is ready to go, but I'm going to have to do a quick conversion of my milliliters into liters. Now, to solve for my number of moles, I'm going to bring my volume to the other side. And multiplying those 2 numbers together, I end up with 0.0301 moles. Now, the volume and the concentration given in the problem were for the ammonium nitrate. So these moles are for ammonium nitrate as well. But that's not what the problem's asking for. The problem's asking for milliliters of dinitrogen monoxide gas. So we need to do a little conversion here. And the first one is converting to the right chemical through stoichiometry. And we see that 1 mole of ammonium nitrate gives us 1 mole of the N2O gas. Now, it may be tempting to go through and look at this and say, oh, I don't even have to do that step. But it's a good habit to get into. And also, if you happen to get a wrong answer, I can provide more partial credit if I see steps like this actually written out. So we have 0.0301 moles of dinitrogen monoxide gas, but we need to convert that to milliliters. And we still have our values of STP that we still haven't used yet. Well, we have a moles, we have a pressure, we have a temperature. That is really all that we need for the ideal gas law. One condition of each. The volume is what we don't know. The gas constant has a value of 0.0821 liters atmospheres per mole Kelvin, and our temperature is the standard of 273 Kelvin. Solving for V means dividing all of the right-hand side by 1, which actually doesn't change it. So I'm going to take my number of moles times 0.0821 times 273, and I could go through and divide by 1 just for completeness sake. But we end up with a volume of 0.675 liters. The question, though, asks for milliliters. So we need to do a quick conversion. Knowing that 1,000 milliliters equals 1 liter, we can easily say that there are 675 milliliters of N2O gas produced. And that would be our final answer.